What's up, y'all? This is a grade 10 practice test, trigonometry informal test 1. The time was 16 minutes given here. All right, let's try and solve this. So 1.1 says you're given a triangle PQR and triangle SQR, which are right angles, as shown in the figure below. All right, so you're given two triangles which are right angle triangles, and we already know something about right angle triangles, that if those figures are given, we already know we can use Pythagoras or we can use the trig ratios. So let's go back to our trig ratios. We normally use Chashotao or Sokator. We know that in order for you to define sine, you're going to say we work backwards usually. It's opposite over adjacent. This gives us tan. Opposite over hypotenuse. This gives us sine. And then adjacent over hypotenuse. This gives us cos. So if we work backwards. Now let's check. Refer to the diagram above. Without the use of calculator, write down the value of tan angle P. So you look at where your reference angle is at. Angle P. That's what we're interested in. So P is right here. That means it's in which triangle? PQR. So if I'm looking at that and I know what my tan is using the Sokator method, opposite over adjacent. So my opposite side will be this one here, and then my adjacent side will be that one there. So this will be my opposite, this will be my adjacent. So and then I can just plug in the value. That is 10 over 24. It's 1 mark. You can further simplify this. So I know that 2 goes 5 times there, and then 2 goes 12 times. So it's 5 over 12. 1 mark. Let's move on to the second one. The sin of SQR. Now we're going to change the reference. So the sin of SQR. Now we're talking about SQR. So this is the triangle we're talking about now. And now our reference angle is the one in the middle. So it's this Q. So we know what the sin is. Sin, you go back here, is the opposite over hypotenuse. So that's what it is. So my opposite side would be this one. This would be opposite. This would be hypotenuse. Remember, hypotenuse is always opposite the 90-degree angle. So then you simply substitute. This will be 6 over 10, which is equivalent to, or it's the same as 2 goes how many times there? It goes 3 times. Into 10 it goes 5 times. There you go. You get another mark there. Let's jump into 1.3. I hope you guys are following. Let me just wrap up this mess. They say the cosine theta. So we're still looking at theta. Theta is in which triangle? It's in PQR. So we now focused on this triangle because that's where our theta is in. Now the theta is here. Don't forget now, the cosine of an angle is the adjacent of hypotenuse. So if that's my theta, this becomes my opposite. That is your adjacent, right? Then that will be your hypotenuse. And therefore, it's going to be adjacent. That will be 10 over 26. Again, you can simplify the fraction. I don't think they'll penalize you if you leave the fraction like that, but it's always safe to just simplify it. So we know we need a number that can go into 10 and 26. I know 2 can go there, it goes 5 times. Into 26, it goes 13 times. Then that's your simplified fraction. Right, and then the last one, okay, I'm gonna get rid of that and this. Let's just get rid of that as well. And the last one there, it's sec. Now remember, you need to know your reciprocals here. Cot, second function, and cosec. Now sec is the reciprocal of sine, so of sin. It's like this or whatever. Cot is the reciprocal of tan. And then lastly, this is the reciprocal of cos. So then here we're looking at this again. We still have this reference angle there. Now we already know that we're talking sine, or the sin of an angle. So the sin of an angle would have been 6 over 10, because this would be my opposite, this would be my hypotenuse. But now I need the reciprocal of this. That means I need the inverse of that. So it's just 10 over 6. And then you further simplify that, that's going to be 5 over 3. So that's the answer to that one. Hope it makes sense. If it doesn't, hit me up on the comments and let's figure things out. Well.